So, on to our topic for today, better software faster, how free quality experts align test data, environments, and automation. A huge thank you to everyone who has joined us today. We've got a great show in store for you. Cool. So now it's my absolute pleasure to introduce you to today's three experts. First, Sanjeev Kumar, Head of Test Environment Management at Infuse. Sanjeev has been a non-production environment manager for over 20 years, leading transformations at Global 200 banks, energy providers, and beyond. He takes a holistic approach to test environment management with deep understanding of its dependencies on test data management, service virtualization, automation, and DevOps. Today, he will kick us off with a discussion on the pillars of effective test environment management, the cost of getting it wrong, and how environments and the data are connected. Deepak Kumar is also today with us. He's the test automation architect and manager at Infuse. Deepak has dedicated the past 14 years to building high-performance test automation teams in industries ranging from manufacturing and higher education to banking and finance. Automation for Deepak empowers teams to work in parallel, test more frequently, and deliver higher quality software faster than ever. And today, he's here to show you how test automation can support test data management. And finally, we have my colleague, Hugh Price, who's chair at Curiosity Software. Hugh co-founded his first test data startup in 1995 and has helped invent some of the first publicly available solutions for data masking, generation, and self-service data provisioning. In fact, Hugh has often been described as the godfather of test data. Today, he's here to show you the components you'll need to integrate test data, environments, and automation, and to achieve the full value out of your tester management efforts. Cool. So, before I hand over to Sanjeev, let's take a look at the results of our poll. And, we wanted to get a better understanding of the areas of quality you're looking to improve. And it looks like all of the above. Of course, that might make sense, but test automation, test data management also stands out. Hugh, is this something that you often see? Does this align to your understanding of the industry?
Yeah. I mean, maybe we should leave it for the end of a discussion on this. I mean, I think, to be honest, you can't really do decent test automation without a good test environment and test data management strategy before. So maybe the people who are interested in automation maybe already have a good test data management or environment strategy. So anyway, we'll chat about it in the end.
Yeah, I think that makes sense. We'll leave it to the end. So, okay, then without further ado, I'd like to pass it off to Sanjeev, if you'd like to take over and get started. You might be muted. Oh, yeah.
Oh, sorry about that.
Perfect.
I'll start again. I'm Sanjeev Kumar. I've been working in test environment management for too long than I can remember. Worked for the banks and mainly, as well as everybody else. So we should get to the next slide, Mantas. I can explain. So the biggest issues that we have in test environment management, and that's what we're going to get to, is everybody has issues, be it unexpected environmental issues that have disruptive release life cycles, the limited number of environments and access to those environments, inconsistent environments. So one thing, you have inconsistency in environments that it works on my laptop, it works in dev, it doesn't work in test, for example. You have a lot of those. Another part of those is you have building those three together, you have unpredictable test outcomes. So the whole question is, it works in dev, doesn't work in test. That's the unpredictable business about it. Then is the resource allocation. How do we allocate? Where do we allocate? And how do I make a testing efficiency better? So if there's a problem here or there's a problem there, where do we prioritize? And that comes down next, which is natural issue resolution. Are we quick enough, proactive enough to fix issues as they arise? Mainly when you do a deployment, or for example, a production refresh of your data. You work today, something's done, the changes happen, and now it stopped working. So issue resolution is key. Do we do that quickly enough? Is there enough data, information, people to support it? And finally, then it's the major issue that normally comes: are we compliant with privacy regulations? And in the banks, especially, there's a lot of GDPR, etc., that's come through over the last few years. So your data there needs to be maintained to provide consistency across all the environments. So they're kind of the main areas, that problems and causes that happen. Ineffective testing management has always leads to delayed in software releases, increases cost because of unreliable test results. So if you go in, make some changes, do some testing, outcomes incorrect, you go live, there's a cost in production. Or you make some changes, you test, you keep on testing, the environment's not available, the code is not of standard, etc. And that will increase your timelines. So everything comes at a cost, and depends how you manage that is trying to reduce your cost. And ultimately that's what test environment management we're trying to do, working with test data and test automation. So if you go to the next slide. Yeah. So at Infuse, we've created a little framework which basically says how to effectively manage your test environments using the 7 pillars that we put in. So this kind of robust framework optimizes your testing process and ensures the reliability and efficiency of your software systems. That's the whole idea. And data operations, as you hear, is very key to why we're having this conversation as well. So quick thing about it, we'll go over the pillars. You have the foundation pillar, which is the laying the groundwork for success. That's just the building blocks of what you have, how it's configured, who wants it, how do I have access, and that what does the foundation piece work. The next bit is the resilience pillar, which is ensuring stability and availability. It's all well and good having an environment. Are they monitored? Are they stable? Are the health checks performed? Etc. etc. How quickly can we recover from those? So the resilience pillar implements those kind of strategies. The orchestration pillar is basically streamlining environment operations. Whatever you want to do, environment setup, environment booking, code deployments, what else is it? Data refreshes, for example, configuration management, deployment, CID, CD pipeline, DevOps. And that orchestration pillar allows you to implement processes and automate those processes so you can increase and boost the overall efficiency of your testing workflows. That's the whole concept of the orchestration pillar. The next one is service support, which is basically meeting users' needs. That is trying to create SLAs. Basically, people raise tickets, people raise incidents. Are we quick enough to respond to those? Are we quick enough to resolve those? What are the SLAs? In non-production, especially, a lot of companies don't have any SLAs. We'll fix it when we can. Please, dev, please, infrastructure team, please help us. And what the service support is that we own that first level support. And that allows us to have an operating team, a support team, that doesn't depend too much on the development and infrastructure team who look on, and the production support teams are looking after production. So we're kind of two different disciplines doing the same thing, but production, as you know, is the most important piece to stay alive. But the test environment management piece, the infrastructure, needs to be there so you could have a proper production environment. I'll come to data operations next, because that was going to lead to my next slide. Then we have enabling technologies. The enabling technology is leveraging tools and technologies. That is the latest stuff that you have out there. You have DevOps, AI, you can have infrastructure as code, and improving, and you can use tooling like Curiosity's TDM tool. So these are kind of spaces that where we implement process, which is fantastic. But what are the tools that help us implement that process? CID is part of AWS, for example, Azure. There's so many out there in the world, self-made tools, etc. So that's what we're trying to do with the tooling, is trying to not recreate everything in the world, especially in the cloud, that is, and reuse technology that enables you to do your TDM and test environment management and your automation more effectively. And then we get to reporting. The reporting pillar is basically the insight, gaining insights for continuous improvement. The reporting pillar focuses generally on creating complex reports and metrics so we can make informed decisions based on the effectiveness of our test environments. These reports, plays a crucial role in facilitating communications and collaborations amongst the different stakeholders. So, as a test environment team, the test team, the project team, the development team, we can say, look at these trends that we've seen, and as well as providing information, SLA, KPIs to the senior management, say how well are we doing as a delivery. And so they're kind of the 6 pillars. The one I want to get to here is the data operations pillar. So the data operations pillar, which is kind of the most crucial part of this whole setup, is is managing test data effectively. Environment management is brilliant. You could have a great environment, but if the data there is not what you want it to be, then you have a lot of issues. So managing test data is critical in our area, and the data operation pillar focuses on ensuring availability, integrity of the relevant test data, while also addressing privacy and security concerns. Now let's go to the next slide, and that should nicely fit in here. So, why TDM? So, why do we need this data? So, as test data management is just to resolve the challenging managing unregulated data. So within the test environments. So data quality is the 4 areas that we need to preserve: data integrity, data quality, data compliance, and data security. So in terms of test environment management, data integrity for us ensures that the test results are consistent and trustworthy, allowing for better decision making made on the outcomes of the test. So the environment itself, everybody's confident that what's in the environment, what tested in the environment, and the results of those tests are accurate, are right, and we have confidence there. The next part that all these kind of integrate with themselves is data quality. Data quality itself, the test data accurately represents real world scenarios and helps in identifying potential issues or bugs in the software that is being tested. Reliable testing outcomes are dependent on the quality of the test data during the testing process, and that test data has to be of the best quality within the environments that we are testing against. Data compliance is the data usage, retention, and disposal of data. Ensuring data compliance within the test environments helps in avoiding legal and regulatory issues, protecting the organization's reputation, and maintaining the trust of customers and stakeholders. So you don't want to have data leakage. You don't want to give, say, for example, in your state, you get a production database, you put in your test environment, and then you can see customer details, account numbers, housing address, stuff. That's we don't want to do. So that data compliance ensures that, as well as the next part, which is your data security. So that which ensures that confidential information remains secure and confidential, minimize the risk of data breach or leaks. That at the end, if that does get out, financial losses, reputational damage for the organization. So that's where you can see the test environment sitting by itself, nice and pretty, doing its thing, staying up, is robust, is available, is configured correctly, is consistent, is doing what you should be doing, and the test data that goes within it is just marries with that. That's how we are totally confident in our development life cycle, non-production from development to testing. So if you're testing a system, UAT, pre-production, for example, you can go from development up to production, all the way through that life cycle, ensuring consistency that what you have tested is validated, and that tested and validated software release then goes in production. And then when you go into production, you should not have the same issues that you faced in your test environments. And that is why it's important. The cost, as I said, is visible as such. But for example, if an environment falls over because for whatever reason you have 15, 20 testers doing testing for 4 days and it's down for 1 day, you lose X amount of hours of work. So a quarter of your activity. Where do you get that back? Where's that slippage going to come from? Where's that money being burnt? And more often, the longer an environment is down, be it physically, if it's infrastructure or it's data, the longer the period it takes to get it fixed. So test environment management in itself is to ensure that all issues are proactively managed and monitored, so reducing as much of downtime as we can. So that's what it is. So test environment management has always been the art of creating the kind of the testing stage, while test data management is the art of crafting data for that testing purposes. Thank you. On to Deepak.
Thanks, Anj. Hello, everyone. My name is Deepak Kumar, and I have been working in Infuse as a test automation architect manager. I have more than 14 years of experience in test automation, transforming the organization towards the test automation delivery, and also working on the different, different kind of applications and environments to implement and improvise the automation, test automation driven testing. Okay, so I will start with my first slide. Yep. So the slide is talking about automation roles and test data provisioning. Before we get into that, I would say there are two aspects of it. So wherever we try to put the automation, as who said in the beginning, until unless you don't have a test data management and test environment correctly placed into the place, you can't have the test automation to be effective test automation process there. So test data management is very important, critical for the test automation to have a very smooth and impactful test automation to be in place. And as it needs the test data management to be in place, also automation can contribute into the test data management. So in this particular slide, we are going to talk about how test data provisioning, automation can play a vital role in test data provisioning. So there are multiple aspects. You can see the test, which is the first one, is the data generation. So through the automation, we can create the synthetic data and generate based on the predefined rules and algorithm. You can write the script which will create the test data, which can be either used by the automation or either used by the functional testing or any other sort of test. So that is one of the way that automation can generate the synthetic or synthetic test data. The second one is masking and anonymization. So masking and anonymization is not about creating the data, but having a data which is either sensitive or personalized information, identification information is related, where you want to mask those data with some, either there are multiple algorithm around it. So you can, play with it based on the definition. You can tweak those information so that you can still use the more realistic data close to the production, but it's not the real data. So that's one of the another aspect. Then there is a data population. So in most of the cases where when we start wherever we go for the transformation to the automation, so people start with the system test, automating system, then integration, then end-to-end test. So when you are moving towards the integration, you are talking with multiple systems, and those systems produce different sets of data. So through the automation, you can collect the data from multiple systems. So let's say you have 4 systems where actual test needs to perform on system 4, but you are fetching the data from test system 1, 2, and 3, and you are massaging those data or manipulating those data so that you can feed into the system 4 to be tested. So that kind of data population can be done through the automation as well. Then there is a data variation. A lot of people have heard about data-driven technique. So when we go for the data-driven technique, we try to test the similar test. So you're trying to do the same functional test with a multiple set of data, verifying the similar flow by putting the edge cases or boundary value analysis and so so on and so forth. So that's the variation of data you can create, and you can test with the multiple data sets. The next one is data cleanup. So as we know, automation, when we develop or when we execute through the automation, we go for the multiple execution cycle, since it doesn't require any manpower. So always automation execution is more heavier in terms of creating, generating data, and performing the test. So it is a responsibility for the automation to clean up those data so that the system would not be getting heavier and heavier day by day. So data cleanup can also be performed through the automation, test automation scripts. Now, the last 3 points is integration with TFS, test automation framework. So when we are saying that automation, test data generation or provisioning automation, it doesn't mean it should be a separate framework. It can be, but it can also be integrated into test automation framework. So within the same framework, you will be generating and managing the test data, or doing the provisioning of the test data, and also passing those data internally to perform your actual testing. Then the next thing is reusability and scalability. So we can use the similar scripts which we have been using. So in terms of data generation, if we write one script to create generate multiple synthetic data, if the data got cleaned up in the environment, we can execute the similar script to regenerate the data. So it can be reusable, it can be scalable as well. And then the last point is consistency and accuracy. So as we know, it's a code, not a human. So we don't expect like your script behave differently in second execution rather than fun, unless you change the code. So it will be consistent and accurate as long as it has been reviewed and code has been frozen. Okay, so let's move to the next section. Okay, so in this particular slide, I'm going to talk about the architecture of the data provisioning, how that data provisioning automation, or I would call it automated data provisioning, how it can be integrated into the test automation framework. So there are mainly 3 parts of it. One is the test management system. That is your automation framework. You can that happens on the top layer of it. So you have in the middle layer, you have the test automation framework, where that integrates with your test management system, whether it is Jira or ALM or any sort of test management tool. And then you have a test automation framework where you have your tools, and on those tools you can say there is a section of utilities. So these are the utilities will be built up to perform the automated test data provisioning, and these scripts are designed on the base of the test data management algorithm rules and predefined rule that has been communicated or guided. And then on the bottom side, you have a data sources. So you can write the script to get the data from different sources like Word, Excel, PDF, Notepad. Also, you can call the API calls with the web services, and you can get the data. You can connect to the databases or even from the websites. So these 3 systems interact with each other. Execution happens, and then the reporting will be sent by the framework, which will say how much data has been created and what is the outcome of that testing. So that's how the very generic automation framework, which has inbuilt automated test provisioning, seems working. And I would conclude that its test automation has a much bigger necessity of having a very robust and defined test data management and environment. And also test automation can participate and help to automate and accelerate those processes. Okay, so that's it from my side. Thank you. Who?
Hey, yeah, thanks, Deepak. I need to, someone else needs to stop sharing, then I can share. There we go, share. Entire screen, there we go. And let's scoot off. Okay, so I'm gonna switch and actually go straight into a demo. Can you guys hear me?
Yeah, perfect.
Yeah, it's good. I'm going to go straight into a demo to kind of tell the story a little bit. You know, we've been in the test data space for a long time, and you know, we've worked to help companies move from a basic set of kind of test data, just copy production over, to very, very sophisticated approaches. And it's a step-by-step process. And maybe after we finished the slides, we can have a little chat with Deepak in terms of how that kind of works. So the first thing is kind of building up a catalog of what data you have. There is so much data in systems nowadays. We live in the age of the API, the ERP systems, and legacy systems all mangled in together. And the first thing you need to do is to be able to properly understand the structures that exist within systems. And the first thing that we do is we would go off and actually just register any structures. That could be Swagger specs, it could be API specs, it could be the databases, it could be XML messages in flight, Kafka messages, or whatever. Now, once we do that, we're then very interested in the relationships between structures and also version management. Now, if we go and look at these are all the various structures that we tend to come in and we capture lots of juicy information about those structures. And if you think about it, the data definitions are really the kind of glue that binds team together. You're handing data off to other teams, whether they be messages or APIs, etc. Now, if you have a central repository or central catalog of where these are kept up to date, where you track all the versions, then people can go to one location rather than just sending messages to people and trying to hunt down various API different things. This also applies to virtual endpoints as well. You kind of need to understand fully what those virtual endpoints are. What we'll also do is we've got lots of lovely juicy diagramming that tells you the relationships between those entities. And what we're doing here is we're kind of grouping them together. We're understanding how these relationships exist, and this is across different technologies. What we can also do is scan the data, and most databases messages, the documentation is relatively poor, and they don't really have things called foreign keys or even very poor Swagger specs. And what we'll actually do is infer those relationships, and we call those soft keys or business relationships. So that comes this concept of kind of understanding. The next thing that we do then is to think about what we have is there are tons and tons of what we call them test data activities, basically. And there's lots of different things that you would do. One of the things you might want to be able to do is maybe generate data. Now, generating data, there are numerous ways to do that. That could be directly into databases. It could be cloning data from other systems. It could be running automation scripts, which Deepak mentioned, and that's a nice way of being able to push data into systems. You can use the front end to do that, or basically use some kind of API harness to be able to do that. Comparison's quite good. Masking, obviously, this ability to make sure the data is relatively clean in terms of privacy information. It will generally not be a very good job in terms it will also contain lots of commercially sensitive information, which you really don't want to have around as well. So it's quite a big job, that one, and it's much more, you could talk about that one for days. So we have this concept of all of these kind of data activities. Now, there's one called general all purpose. Now, what that is for all of the stuff that you already have. Generally, there will be lots of nice stuff lurking around in your organization, which people use. They've written themselves, Perl scripts, maybe some Excel spreadsheets, etc. And the first thing to do is corral everything together so that they all kind of live inside a portal. And then that allows people to make requests through the system to be able to find or make or provision data. Okay, so now if we kind of moving along a little bit. Now, the first thing that people tend to do is to try and find data. If you actually, people testers spend an inordinate amount of time trying to hunt for data across multiple systems. Now, it's kind of a big subject, but what we tend to do is we turn that into a very structured approach. And what we'll do is we build little mini data warehouses, and we have a little mini database sort of cluster that we ship that allows you to extract data from multiple systems. I think Deepak mentioned 4 to 5 systems being typical, which I would agree with. And that basically allows you to go off and kind of build for this set of environments under test, build me kind of an aggregated view of the data that exists in there. You can populate that in real time, or you can basically populate it, just sort of at the beginning of the day or whatever. Within that, you then give them forms, which then allow, and this is probably about 30% of our time in the test data land, is being able to say, well, we want some of those, what's the last order date? And basically what we do then is we allow people to make all their requests for data through one location. Now, what does that mean? That means that all your manual data requests, your data scenarios, are coming through one clean location. Coming back to automation, what we can also do is basically convert that into an API request. And then in effect, what would happen then is you attach that to your automation test comes along, you give it the characteristics that you want for the data, and we would then go and look up the data in the system to make sure that you have the right type of data. And that is probably the number one problem with automation, is you don't have the right data. And when you get a failure in an automation script, which has been running happily for 2 months and suddenly it stops working, it's because the data has changed or shifted, or the account number that you're using has changed its status. Now, what we'll also do at this stage is we keep track of, let me find these allocation. We keep track of all of the data requests. So as people have made requests through, and this would again be for automations, etc., what we're actually doing here is we're actually tracking. Oops, sorry. Let me just go back in, lose that. Okay. Once you go over here, you're basically keeping track of all of the different requests that have gone through. And also we allow them to reserve the data so you don't get cannibalization. So here we've got basically, so over here, these are the keys. Actually, they've all expired. No, here we go. So these ones here haven't expired. That means that those are now basically held for me until the end date. So this ability to find data in a structured and organized way is probably the number one thing you can do immediately for your manual testers, for your business analysts, etc. How that summary table gets built, that's where automation can play a part as well. You can go and automate the harvesting of data into these aggregated pools of data, because quite often you can't get data from an ERP. You might have to run a report and parse it. But that's kind of a good place to start. The next thing I'm going to talk about is kind of provisioning environments. Now, you generally, you can spin up lots of virtual databases now. There's great products like Windocs, etc. And that allows you to spin up, hundreds, or, and if you really are talking about sort of dynamic, really reactive DevOps, this ability to spin up individual databases is kind of fundamental. You should be able to spin up 10 of these. You should be able to clone them. You should be able to create lots and lots of them. But fundamentally, what you also want to be able to do is to build the right set of data in there. So what we do is we have this concept of a pipeline. It's kind of a common term in, Databricks uses that term, etc. Now, we're obviously focused on the provisioning of environmental data. And what we have here is we've got a couple of schemas. This one is our main development one, but to be honest, I want to kind of have my own QA one, which is a bit cleaner without all the noise in there. If you look at it, it's currently empty. And what we have here is, first thing we want to do is do some validation. Now, validation is checking all those foreign keys, all those business rules to have a look at the quality of the data in there. We're then going to do some subsetting, and subsetting is crawling across the data. We're going to do a bit of plumbing. We're going to do some masking. Let's have a look at the masking. If we look at the rule sets for masking, what you'll see is that we've gone through, we've scanned the data, we've auto-applied different types of rules, and there's a whole world of stuff that you can do in here in terms of being able to mask that data, addresses, names, account numbers, etc., etc. So The next thing we do then is say, well, that's nice. We've got a nice clean database. We've masked it as we've moved it. And then we also want to supplement the data within that database. And in fact, what we're going to do is we're going to allow the user to create a whole set of orders in certain statuses with today's date, because quite often the data is out of date. And finally, we're going to validate it. All of this stuff rolls up into one of our request forms, and we will, sorry, the wrong one, subset mask, which is this one. Sorry, this one here, which is that one. Yep. Now, what you'll see here is we are picking various suppliers that we want to pull out. We're going to mask the data. We're also maybe want 1,000 customers. We want those. We're interested in. We're interested in cancellations. We're setting up various values. You fire off the job. That then basically runs through and does some, relatively sophisticated stuff. And what we're doing here is this is the scanning at the beginning. We've actually got some bad data lurking around in our development environment, which is quite common. We then basically come along and subsetted the data. We've crawled across the database. Here we've gone in and we've basically then generated some data along the end, and then we've also done some validation. And in our target environment, we've got no errors. And if you switch then and go over, you can see we've got a much smaller set of data, but we've got just the suppliers that we want. It's nice and clean, and we've also supplemented it with a whole bunch of customers and orders that we need. So it's a much more sophisticated way of provisioning up these kind of much smaller and much more fit for purpose type environments. You could use them to create training databases. You could use them to use sort of regression test databases with very clean sets of data. So that's one. I would say another one which is becoming increasingly popular. The problem with environments with databases, if you copy an entire environment, people say, oh, we haven't copied production data for 3 years. Good. Yeah, that's good in my books. And what they're trying to do is they want to bring over a copy of production. They want it to be masked, and they want to do that sort of once a month. The problem with that is that people are working in their dev QA environments, and suddenly that whole environment gets blatted. It's gone. So one of the things that we do a lot of is this idea of cloning data. So rather than pulling in the entire database, we use a variation of subsetting. And what we're actually doing is, in this particular case, we're just in effect pulling out sets of suppliers that we're interested in. And we keep track of all the relationships between them. And if we go and look at the suppliers, we're actually pulling data out from one environment. We're reassigning all the keys. So we'll get a new key in there. So you'll get a new supplier ID. Now I can also play around with the data as well as I'm moving. In this case, I'm just changing the names. So I'm just so that this is a clone of the original one. But you could also come in and do dynamic masking if you wanted to. You could also maybe, move the dates to be current or anything like that. And this idea of being able to pull out interesting data from one environment to another, create a new version of it, is a much sweeter and nicer way and less disruptive. You can also use it to bulk up data. If you think about automation, so you have 50 automation scripts which close accounts. Once those accounts are closed, you've lost them. So what you might want to do is basically start with a single account and create 50 of it before you even start the automation, and then make sure the closing all works correctly. Also, if you've got long chain histories, which is typical, very difficult to recreate those long chain histories, but the ability to clone them is kind of very important. The other one then is messages. Now, I would say probably coming up fast for us is the ability to build these complex payloads. Now, what I've done here is just actually used, this is Equifax, I just pulled this off the internet, which is basically, they have structures of messages that they want to create. So I said, well, that's interesting. What we'll do is we're going to synthetically generate lots of variations of those messages. So again, we create a pipeline. The pipeline, in effect, is built automatically for you, and it allows you to say, well, I'm going to create the header, I'm going to create this, which is the consumer reports. I think that's one of the things. And then you're basically going through and being able to create these kind of very sophisticated payloads. Now, if you're thinking of testing, first thing you want to do is create lots of bad data. So especially for things like payment systems or any kind of things in retail, what you also want to do is to make sure that data gets rejected. So you might want to spend a bit of time, in effect, building sets of bad data as well while you're at it, and that's a useful way of being able to kind of drive better testing, because if you can make sure that all the bad data doesn't get in at all the entry points, that actually means that lots of the bugs don't show up immediately. They show up a bit later once the system has once the data's moved about halfway across the system. So that ability to build these complex payloads is big, I would say, and this can be pushed into APIs, Kafka messages, onto mainframes, etc. The other one is understanding density of data. I'm going to talk a little bit about coverage now. Now, the thing about everyone says, "Oh, production data is gold copy." Gold is one of probably the phrases I hate most in the world. The problem is that you want your development and QA systems to have a much more sophisticated sets of data. So what we'll do is we'll mine the characteristics of the data. And what we'll do then is say, well, okay, let's go and have a look at this. Let's just fit to view. And what we've done is we've picked various characteristics. Again, this is some synthetic data I used to do with, I was just doing company credit ratings just for a bit of fun. And here you can basically go in and have a look at the densities of data to see the different variations of data that you've got. Now, that's quite interesting because obviously that shows us the gaps, and you might want to say, well, I just want to fill in the gaps there and just, maybe to use some data-driven testing and automation to populate these types of variations. What you can also do is compare the data across different systems. So you can come in here and say, well, let's show me the differences between them. Actually, these are fine. Everything's looking good between. There we go. So these are basically, we've got kind of the Venn diagram of the different types of things. And what you really want to do is to make sure that you have all of the characteristics of production in development. And in fact, what you also want to do is to prove that in development you have more variations of data. Okay, so that's and then you can also then go off and use things like all pairs, orthogonal arrays, constrained all pairs, etc. And we have that built into the tool to be able to do that. I'm going to finally talk about modeling and also maybe a little bit about AI. Now, this is basically a requirement document, but everything you look at here is data. It's basically, we need data. It's got the day of the month has got to be, beyond the 15th, less than the 15th. It's the next, etc., etc. So it's this ability to be able to model out the variations, and within that, we then have each one of those. It's a distinct set of data. If you come and have a look at invalid data, you'll see. Sorry, let me not do that. Let me just do that again and just expand. So here you'll see that we've actually got each one of these is actually some invalid data which you could drive through, and actually, as you'll see, there's a lot more combinations of that. So this ability to model out the variations of data, and again, this is good if you want to drive automation with this kind of concept as well. The final thing is just to talk a little bit about artificial intelligence. Now, one of the things that you can do, AI is very good at being able to take textual stuff, and this runs for about a minute, so I won't bother running it. So basically what you do is we've got a thing called Copilot, and what that allows you to do is to take maybe a requirements document, a stream of consciousness, a set of user stories, and you can see these have been pushed into the tool. What we'll do for you then is we'll actually just do a generate model. If I click on that, that's going to go off and actually just go out and use some AI. That will then come in and actually build you models, and some of our customers are actually using this to verify the models that people have verify the requirements and models match. And if you look at the Copilot, actually, you'll see that there's lots of different types of equivalence classes, basically localization, model review, model summary, etc. There's lots of different things within there, and you can expand that yourself as well. Now, that is going to give you the definitions of the variations, but actually what you tend to do is, is AI good for everything? No. Once you actually see it visualized, you will tend to improve it, and then you can run it back through the Copilot as well. And that's also a really nice way of being able to generate synthetic data, or to make sure that you found the right data. by being able to make sure that you can actually test this scenario, which, as I said, was in effect, that, which is only about 6 or 7 lines, but actually to be able to test it, thoroughly, you need to make sure that you've actually modeled it out and have a very good set of data. Okay, fine. I think that's enough of me talking. Do you want to just quickly go to do the slides, if you don't mind? I'll stop sharing, Mantis.
Sure. Yeah. There you go.
Okay, so I'm just going to do one slide. So I think the most important thing about a test data strategy is that it is evolving. It needs to come from the bottom up and the top down. It needs to come from the top down is that the management do need to realize that the ability to have a good test data strategy improves your quality, probably reduces your the number of sprints to release by maybe 20%, maybe 1 sprint in 5 will be improved. It also allows your team to work in parallel, and it also drives you to the concept of DevOps. Everything else is pretty much fluff. Without, the data within your system is the most fundamental thing. That is, in fact, what the whole system is for. You can get hung up on UI testing tools, you can get hung up on all sorts of things about productivity and things like that. But without a fundamental understanding of the data, you are going absolutely nowhere slowly. If you want to outsource, you need to be able to give people really good quality data. You need to give them good, clear specifications. And the only way to do that is to drive in very, very good data with the expected results, which you've got from your model, as part of those requirements documents as well. So that's it. I would say that, we've built lots of test data management teams. You don't need people to be super experienced. You just need people to be curious, hence the name of the company, in terms of being able to understand the complexities of how data is related and being able to explore and create the different types of data. You need a systematic approach. You need people to buy into the concept that they have to probably think a little bit harder at the beginning of their work rather than panicking halfway through or at the end. And again, this is all, as Deepak and the team will know, is kind of fundamental to good quality and good processes. You can generally start with possibly 1 or 2 junior engineers who just start maybe just finding data in a more organized way. Then you move into synthetic. Then you look at the environments and how you populate data into automation frameworks, which probably comes next, to make sure you've got much more stable automation frameworks. And then you start building out this, it's enterprise data management, where you're building out a catalog of all the data within your organization, and allowing that catalog to be the communication layer between different teams, rather than having to contact a team and say, I've noticed you've just changed this API, what the hell's going on? They should just be able to look at the Swagger spec, see what's happened, see the difference, make the changes to their system and move on, without really having to get into big panics. And that should just be a notification that a change has gone on. So that's probably enough. What's the next bit?
Yeah. Do you want to keep going, or would you like to?
No, I think that's fine. I think
Brilliant.
we've got 10 minutes. We've got 10 minutes left now, so let's maybe just open up to Deepak or the team.
Awesome.
And just chat a little bit.
Yeah, cheers, Hugh. Just to say, all the slides will be shared with you. The complete slide deck will be shared with all viewers. And so thank you, Hugh, Sanjeev, Deepak, for the great presentations. And before we move on to the Q&A section, I'd like to give a quick overview of our free strategy workshop that we're offering to all our viewers of today's webinar. So please, there'll be a little poll that's going to start just now. You'll see in the interactions bit on the right-hand side. But yeah, just to say, we are offering, Curiosity and Infuse are offering you a free, no obligations, current and future state analysis workshop that will tackle test data, test environments, and test automation. If you're interested, hit that yes option in our in-webinar and post-webinar polls, and we'll have an expert reach out to you with a survey. We'll then organize a remote or on-site workshop with your teams aimed at helping you overcome your automation environment and test data challenges. You'll also receive a free bespoke report and recommendations. So if you'd like to have one of our experts join you for a personal workshop, then please hit that yes button on the poll. Cool. So yeah, now let's talk Q&A. We did get a nice short question for you, Hugh, from Deborah, asking, in your demo, it looked like you were doing, you were showing SQL, SQL databases, and the question is, what about Mongo databases? Do those work with ETD?
Absolutely. The world of tech has just gone absolutely crazy and exploded the whole time. Within them, you end up with JSON structures embedded in. You end up with documents. You end up with Avro documents, etc. So, everyone gets slightly freaked out when you have these other database structures, but on the other hand, or document structures or whatever you want to call them. So yes, we do support them. There are some other tools which we occasionally use just to kind of help us bring data in and push it back out again. But for the most part, we have native support for most of the major stuff, and we have worked with MongoDB in the past.
Awesome. Thank you, Hugh. So just to say, if you do have questions, please leave them in the chat or private chat boxes. But I do have a question for you, Deepak. So just looking back at the poll we ran at the start of the webinar, the results came in that majority of the participants in the poll said that test data management is the area they're looking to improve the most. Is that something that you found in general, something that you've experienced with your clients and customers, that test data management is something they struggled with?
So test data management been always a challenge, to be very honest, and specifically when you want to implement automation, right? It consume, as I said, it consume a lot of data, and depend upon like how the test environment and test data management has been set up in the organization, and how much data dependencies on the system. So in general, most of the test automation runs from the dev to SIT, and the moment it moves from the SIT, means from tester hands to the business hands, that is where mostly, I would say, system goes into the into a mode where they move from synthetic data to the data that has been masked or used some kind of organized data, which is more close to the realistic world. So yes, test data management being always means a challenge for most of the clients. Few clients, they have the sensitive data, they are playing with a lot of data, they have placed the strategy and all those stuff, and all the good stuff that who was showing. It's all depends upon what is their necessity and how much they are dependent on the test data, to be honest. So it varies client to client, but yes, test data management is being a challenge.
Awesome. Yeah, thank you, Deepak. Sanjeev, I have a question for you. Do you think, in general terms, do you think that there's a perfect test data strategy out there, or will there always be room to improve, always room to learn more? What do you think?
Yes, there's always going to, there's not the perfect strategy. There'll be strategies per organization based on the environment requirements. For example, you have the big banks, they like to copy production data, then run batches for T+0, T+1, T+2, and that could be a big sprint. And then they want to save that data somewhere, this database somewhere, and then can we replay it again? Can we bring that back alive again? And having a strategy that allows you to, one, create those databases, second, action those databases, and third, not delete them and then bring them back again and start again, is fantastic. Because I normally, well, if you don't have one, is you can put a request in production, get the data mask it, and run this test again, and has in the demo provided. If you can clone and create those entities beforehand, it saves you a lot of time. So a work in test environment management and test data management, as they both work hand in hand, I think they complement each other as much as we go along.
Awesome. Yeah, brilliant. That makes a lot of sense. So yeah, I think we're coming just about to come up on time. So I'd like to start to wrap things up. Please, if you're interested in learning more, book a meeting with Infuse or Curiosity. Please follow us on LinkedIn and other social platforms, and reach out if you have any questions, thoughts, or feedback. We'd always love to talk to you. And yeah, so I think all that's left to be said is a huge thank you to our three experts today, Sanjeev, Deepak, and Hugh. Thank you for presenting today. A massive thank you for everyone who tuned in. And yeah, I hope to see you all next time. Thank you, everyone.
Thank you.
Cheers. Thank you.
Bye.
Thank
Bye.
you. Bye.
Bye.